We live in an ocean, but not of water. Around us every moment, there is a sea of invisible waves. They flow through walls, slip across streets, dance above cities, and even reach into space. They carry our words, our music, our memories. They shape how we work, how we play, how we love. This ocean has a name. We call it Wi-Fi.
In the 1860s, James Clerk Maxwell sat at his desk drawing equations that described the unseeable. He predicted that electric and magnetic forces were not separate, but bound together, rippling through space as electromagnetic waves. At the time, it was pure theory. No one had ever seen such a wave. But Maxwell wrote, with quiet certainty, that they must exist. 20 years later, Heinrich Hertz proved him right. In a small laboratory, he created sparks that leapt across a gap and sent ripples through the air. Invisible ripples. When asked if this discovery would change the world, Hertz shrugged. "Of absolutely no use," he said. He had no idea that his sparks would one day connect billions of people.
By the early 1900s, inventors like Guglielmo Marconi used these waves to send Morse code across the Atlantic. Suddenly, the world was smaller. Radio was born. Then, television. And in World War II, radar turned invisible waves into a weapon that could see across the sky. Electromagnetic waves had gone from a curiosity to the nervous system of civilization.
By the 1970s and 80s, computers were spreading, but they were trapped, tied down by cables. The internet was being born, yet moving data required miles of wiring. Scientists dreamed of something more, a world where information could leap across the air, free of wires. In 1997, that dream became real. Engineers finalized a global standard. Its technical name was IEEE 802.11. Not exactly catchy. So they gave it a new name, Wi-Fi. A word with no meaning, but with the sound of the future. No one knew it yet, but this technology would soon cover the Earth. So how does Wi-Fi work? Think of your router as a storyteller. It takes digital information, ones and zeros, and tells the story by encoding it into radio waves. These waves ripple outward at billions of cycles per second, 2.4 billion to be exact. That's why we call it the 2.4 gigahertz band. Later, we unlocked faster highways, 5 gigahertz and soon 6 gigahertz. Each frequency band is like a lane on an invisible freeway, carrying data in streams of light-speed traffic. Your phone or laptop listens, decodes the story, and turns those waves back into text, video, and sound. All of this happens so quickly, so seamlessly, that you never notice. But in reality, your device and your router are whispering to each other billions of times per second.
Here's something astonishing. A Wi-Fi signal is weaker than a light bulb. Your router often transmits at less than 1/10 the power of the flashlight, yet it can fill an entire house with connectivity. Wi-Fi waves travel at the speed of light, 186,000 miles per second. A message can circle the Earth in less than a blink. In 1 second, your router may transmit millions of packets of data, each containing tiny fragments of your videos, calls, or messages. And yet, it all feels instant, seamless, effortless. That is the magic of invisible engineering. Today, Wi-Fi is everywhere.
In homes, in coffee shops, in schools and hospitals, in airplanes flying miles above the Earth, even in the International Space Station, orbiting hundreds of miles above us. The average American home now has more than 20 devices connected by Wi-Fi. Phones, TVs, game consoles, even refrigerators and doorbells. Without Wi-Fi, our world would grind to a halt. Entire industries would collapse. Education would stall. Families would be cut off. We rarely stop to think about it, but every heartbeat of modern life pulses with Wi-Fi.
Yet the invisible ocean is not without storms. Wi-Fi signals are delicate. They bounce, they scatter, they weaken through walls. A neighbor's microwave can interfere with them. The very air is crowded with competing waves, cell signals, Bluetooth, satellites, and countless other transmissions. To survive, Wi-Fi constantly adapts. It changes channels, splits data, retries failed transmissions, and corrects errors, all in microseconds, far faster than we could notice. It is not just a technology, it is a living dance of resilience. But the story does not end here. Wi-Fi 6 is already here, capable of serving dozens of devices at once with lightning speed. Wi-Fi 7 is on the horizon, promising connections so fast they will rival fiber optics. In the future, researchers imagine Wi-Fi beamed across entire cities with invisible lasers, satellites blanketing the globe with seamless wireless coverage. Some scientists are even exploring terahertz waves, frequencies 1,000 times higher than today's Wi-Fi. With them, we could transmit a full-length movie in less than a second. The invisible ocean is growing deeper, richer, and faster than ever.
From the chalkboard of James Clerk Maxwell to the sparks of Heinrich Hertz to the routers in our homes, we have learned to ride the waves we cannot see. Wi-Fi has become more than technology. It is the lifeline of modern civilization. We are all swimmers in this invisible ocean. We surf its waves every day without ever seeing them, without ever touching them. And yet, they carry our voices, our stories, our lives. This is Wi-Fi, the invisible thread that ties humanity together.